Good morning, one and all. In today's class, we are going to see about the analog to digital converter. In that, we are going to see about the two types of integrating type analog to digital converter. The first type is single slope ADC. So here, assume that the positive analog input voltage is applied at the non-inverting input of the comparator. Now, when a reset signal is applied to the control logic, the 4-digit decade counter reset to 0 and the ramp voltage begins to increase. Since Vi is positive, the comparator output is high. This allows the clock pulse to pass to the input of the 4-digit counter through the AND gate and the counter is incremented. This process continues until the analog input voltage is greater than the ramp generator voltage. Whenever the ramp generator voltage is equal to the analog input voltage, the comparator output becomes negatively saturated or logic 0, and the clock is prevented from the passing through the gate. Chasing the counter operation, then the control logic generates a strobe signal which latches the counter value in the 4-bit digit latch, which is displayed on the 7-segment display. The displayed value is then equivalent to the amplitude of the analog input voltage. So this is about a single slope ADC. In dual type A to D converter, the integrate generate two different ramp. One with the unknown analog input voltage Vi as the input and another with the known reference voltage Vr as the input. Hence it is called dual slope A to D converter. So here in this diagram, assume that the 4-digit decade counter is initially reset to 0000. The ramp voltage Vs is reset to 0 volt. The analog input voltage is positive and the input to the ramp generator or integrator is switched to the unknown analog input voltage first. Since the positive analog input voltage is connected to the inverting input of the integrator output Vs is the negative ramp, while the comparator output Vg is positive and the clock is passed through the AND gate. This results in counting up of the 4-digit decade counter. Once the negative ramp will proceed for a fixed time period T1, then which is determined by the counter deductor for the time period T1. So at the end of the fixed time period T1, the ramp voltage is given by Vs equal to Vi divided by Rc into T1. So once if the counter reaches the fixed count at the time period T1, the count deductor gives a signal to the control circuit, which is in turn reset the counter to 0 and switches the integrator input to a negative reference voltage minus Vr. Now the ramp generator begins at minus Vs and increases upward until it reaches 0 volt. During this time, the counter gets advanced. When Vs reaches 0 volt, the comparator output will become 0 and the clock inhibited from passing through the AND gate. Now the conversion cycle is said to be completed and the positive ramp voltage is given by Vs equal to minus Vr divided by Rc into T2. Since the ramp generator voltage starts from 0 voltage and decreasing down to minus Vs and then increasing up to 0 volt, the amplitude of the negative and positive ramp voltage is equated. So the equation, the first minus Vs equation and the next plus Vs equation is equated, and your input voltage Vi minus Vi equal to Vr into T2 by T1. So it is obvious that from the above equation it is clear that unknown analog input voltage is directly proportional to the time period T2. So because Vr is known reference voltage, T1 is the predetermined time period. Thank you.